All right, today we're looking at the area between two curves. The idea here is we have some curves made by g at f of x, and we're looking to find the area bound between them. So that's this area right here. We're going to find that area right here. So if we think back to our geometry days, and we're finding the area of a shape inside of another shape, so like let's say we had a square and then a circle, and we want this area right here. Well, what we do is we do the area of the square minus the area of the circle, and that would give us the area of the leftover space. So if we think of these as shapes, we're looking for the area of the upper shape, which would be this purple one, that shape, and we want to subtract out the area of the blue shape here. I didn't even change the color. So of the blue shape here. So that's this one right here. Notice they go through the intersection. So if we find those intersections, we could say this is the integral from a to b of the area of purple from here down to the x-axis is going to be just f of x minus, and then the area of blue, which is just under here. And that would leave us with just that spot in between them. This is the idea behind the area between two curves. So when we look at this one, we want to find the area between x cubed and x squared. The first thing we would need is those endpoints, and then we need to figure out what's on top and what's on bottom. Well, let's check the intersections first. So x cubed equals x squared. X cubed minus x squared equals 0. Factor out an x squared. So we end up with 0 and 1. That's the intersections. The issue is we don't know what function is on top. So what we need to do, we need to pick some number between 0 and 1 and plug it in and figure out which one's going to be bigger. So let's say 1/2. So f of 1/2 is going to end up being 1/8. G of 1/2 is going to end up being 1/4. So g is bigger, so when we set this up, we need to do g of x minus f of x. So this will be the integral from 0 to 1 of x squared minus x cubed, and then we'd work it by hand. X cubed over 3 minus x squared over 2, or fourth over 4. From 0 to 1, plug in the 1, we get 1/3 minus 1/4. Plug in 0, we get 0. So this is going to be 1/3 minus 1/4. It's just going to be 3 over 12, or no, 1 over 12. Ooh, took me way longer than I like to do that. 1 over 12 there. All right, and there's more problems we can do, and we'll look at some with calculators as well. Sometimes you'll see ones like this, and we'll say something like the first 2 intersections, because there's an infinite number of intersections there. We could say the area bounded by these 2 equations, and you'd have to set them equal and solve for the intercepts. The biggest challenge for these problems is just finding the intersects and finding which one's on top. We could do one like this, where I'm just asking you to write the integral but not solve. All right, so we could find where they intersect, write the integral, and not solve it. There's not much variety to these. I just wanted to give you some examples of problems you might see and the general steps to find it. All right, let me know if you have any questions. You all have a great day.